On this one, we're going to have a phase shift. We're going to have a change in amplitude, but we're also going to have a different period. Let's try to work with all of those elements before. Let's start by working with the amplitude and the period. So this is going to have a period, an amplitude of 3. Let's start with the amplitude 3 and minus 3. Now, if you look at here, you have a 2. That 2 needs to be outside of the parentheses, and the usual period is 2 pi. But because we have k or b, if you're using Alex, you're going to do 2 pi divided by k. So 2 pi divided by 2, that means that our new period is going to be pi. So we're going to have less space to sketch your graph, but it's going to be just enough to get what we want. So let's find what we need. Let's set those limits. And now we're dealing with sine. So I'm going to, if pi, I'm dividing it into 4 pieces. This is going to be pi over 4. 2 pi over 4, that's pi over 2. And then we have 3 pi over 4. If you want to make the subdivisions, go ahead. You could subdivide this just to get an idea of where those points are going to end up. On this one is pretty clear because the lines are already there. Once you have that, we know that sine has a starting point of 0, 0, and it's also going to end up here. We're going to have an x-intercept. In between those two, we have another x-intercept, and then in between the x-intercepts, we're going to reach the maximum value, and in between the other two, we're going to reach the minimum value. And the sine wave is going to end up kind of like this. So once you have your sine wave, we have dealt with the change in amplitude, the change on the period, and now we have a phase shift of positive pi over 4. So that means that now we're going to push our graph to the right. So this point is going to jump here. This point is going to jump to this new place. This point is going to end up here. This one is going to end up here, because if you notice, pi over 4 is just 1 square. If you were asked to push the graph pi over 2 units, you would have to jump 2 squares. So it depends on how much you're shifting your graph. If you were shifting this 3 pi over 4, you would have to jump 3 squares to the right on every coordinate. This one is simpler because it is right next to it. And once you have shifted every coordinate, you can sketch your new graph, the green one, and it's going to look something like this. If you notice, the distance between the starting value and the end of the cycle of the green one is still pi. Even though it's not as clear as before, because you're not starting at 0, it's the same distance. So the period is still pi, even though we're not starting at 0, 0. So once again, it's just a matter of setting your boundaries, finding the amplitude first, the period, and once you have that, once you're sure of all of your coordinates, you can do the phase shift or even the vertical shifting. Once you have this phase shift, you could push every coordinate 1 unit up if needed. So it's just a matter of going 1 step at a time, or using your table of values, your coordinates, and then finding the coordinates first. That's the approach that Alex is going to lead you to. This is another approach that you can use. So you can use both. And in this case, it's always better to have an idea and to write down the coordinates. So I'm going to write the coordinates next to each point. This ends up at pi over 4, comma 0. This one looks like we're at pi over 2, comma 3. Then this one is 3 pi over 4, comma 0. Then we are at pi, comma minus 3. We didn't label this one, but that's 4 pi over 4. So this is 5 pi over 4, comma 0. So it's always better to know the coordinates. Even if you're not using the table, you still can get your coordinates.